As Earth's closest planetary neighbor, Mars has long been seen as humanity's most promising second home. Scientists have placed their hopes on the red planet, not Venus, even though Venus is closer. The reason lies in Mars's unique history. It is the only planet other than Earth known to have once had flowing liquid water. And at one time, it may have hosted a massive ocean in its northern hemisphere. However, these conditions likely existed only during the first billion years of the solar system. As Mars lost its global magnetic field, its oceans and atmosphere gradually disappeared. Therefore, to revive Mars, we would essentially need to restore it to its state 4 billion years ago. According to scientific consensus, the first stage of terraforming Mars, called the geodynamo effect, requires meeting 3 key conditions: increasing the atmospheric mass to significantly reduce surface radiation exposure, introducing stable liquid water on the surface, raising the surface temperature by approximately 60 degrees Celsius. To achieve this, the first step is to increase the concentration of carbon dioxide, CO2, in the Martian atmosphere. Utilizing the greenhouse effect, calculations show that the polar ice caps on Mars contain enough CO2 to raise surface pressure from its current 6 millibars to 100 millibars. Additional CO2 trapped in the regolith could push the total pressure to between 400 and 500 millibars. If future technologies can melt these ice caps, the system could become self-sustaining. Melting the southern polar ice would release small amounts of CO2, raising atmospheric pressure and triggering a greenhouse effect. The added heat would further melt ice, releasing more CO2 and enhancing the warming cycle. While this is theoretically sound, how could it be done practically? British astronomer Paul Birch proposed building a massive mirror with a radius of 125 kilometers designed to reflect sunlight onto Mars' south pole, raising temperatures there by at least 4 degrees Celsius. This would convert frozen CO2 currently in the form of dry ice back into gas. If positioned directly above the Martian South Pole at a distance of 214,000 kilometers, not in orbit, but in a polar stationary location, the mirror could heat the polar cap regions above 70 degrees latitude. Technologically, such a structure would need to be constructed from polyester film, just 4 microns thick and coated with around 200,000 metric tons of aluminum. This feat would be impossible on Earth and would rely on the development of future space or lunar industries. Elon Musk once suggested detonating hundreds of nuclear bombs at Mars poles to release all stored CO2